Today we move on to intersecting lines part 2. So some interesting things to notice. First, it said, use the figure below to answer the following questions. Number 1, measure each angle in the figure above. So I went through my protractor and I measured, and you'll notice that there's only 2 different measurements in the entire diagram. Angles are either 52 degrees or 128 degrees. So the first question for us to answer is, which line is the transversal? So which line is the one cutting across at least 2 other lines? And that would be line C is the transversal, cutting across lines A and B. Now, what do you notice about lines A and B? They appear to be parallel. So we can say, number 1, they appear to be parallel. We can also talk about some notation. So line A, I put the line symbol above A. It has arrows going in both directions because it continues on forever. Is parallel, which is just 2, looks like lowercase l's. That's the symbol for parallel. And then line B, again, the B with the line symbol over it. So give an example of some vertical angles. Vertical angles are the ones that I also sometimes call scissor angles. And vertical angles in this case would be, for example, 2 and 3. They are open the same amount, you'll notice, right? Angle 2 is 128 degrees, angle 3 also 128 degrees. So I could say angle 2 and angle 3. Notice I didn't use the plus sign. I'm not adding them together. I'm just listing a pair. What do you notice about the angle measures of the vertical angles? They are congruent, which is the math word for equal in size. Give an example of corresponding angles. So corresponding angles are the ones that were in the same location. So we might say that one pair of corresponding angles, angles that are in the same location, for example, would be maybe angle 2, which is in the upper right corner, and angle 6, which is in the upper right corner. So I might go with angle 2 and angle 6. What do you notice? Well, angle 2 and angle 6 are also congruent. Give an example of alternate interior angles. So alternate interior angles were ones that were inside. Now this time we're saying A and B are here. They're going side to side, or they are horizontal. They're your highways, right? They're your northbound and your southbound. So I'm looking for alternate interior angles, ones that are inside the highways, one above, one below the transversal. So I might say something like angle 4, which is on the right side of the transversal, and angle 5, which is on the left side of the transversal, but they're both interior. They happen to also be the same size. Angle 4 and angle 5, they are also congruent. Hopefully you're noticing a pattern. And last but not least, alternate exterior angles. So ones that are outside the parallel would be something like 8, and it is on the right side of the blue transversal, and 1, which is on the outside of the blue transversal. So I could say angle 1 and angle 8, and they are also congruent. So very interesting observations. The ones that we have talked about so far, the terms that we've defined, also are angles that happen to be congruent. Now, if we use the figure below, you will notice that this one does not look quite as organized, all right? It says measure each angle in the figure above. So I would be measuring with my protractor things like 150 degrees, 30 degrees, 85 degrees, 95 degrees. Over here is 85 degrees. Well, that's interesting. Over here is 95 degrees. Okay, so I'm seeing some matching here. Angle 7, 150 degrees, and angle 8 is 30 degrees. So that's very interesting. Right now, which line would we say is the transversal? The one line that's crossing at least 2 other lines would be line P. And are Q and R parallel? Do Q and R appear to be parallel the way highways would be or the way railroad tracks would be? And we would say no, they do not appear to be parallel. Give an example of vertical angles. Again, vertical angles were like our scissor angles, and vertical angles are the ones where we open the pair of scissors really, really wide, and our handles are really, really wide, and the blades are really, really wide, and they are facing opposite directions. So a vertical angle pair, in this case, could be angle 1 and angle 7. And you will notice that vertical angles are still congruent, right? If I open the scissors really wide, my hands open really wide, the blades open really wide, that does continue to work. But you'll notice that the angles over here on the left vertex do not match the angles over here on the right vertex the way they did when the 2 lines were parallel. Give an example of corresponding angles. So are the corresponding angles congruent? So here, let's try to get both of these on the screen at the same time. And this is going to be a little tricky, but I'll do my very best. Corresponding angles, so angles in the same location. So angle 1 is in the top left and angle 3 is in the top left. So if I said angle 1 and angle 3, they're definitely not congruent. Angle 1 is huge, angle 3 less than 90 degrees. Are they congruent? No. Alternate interior angles. So inside Q and R, which clearly do not look like highways, but if we go inside, one above, one below, angle 2 and angle 6, we can say that they're alternate interior, but they are not congruent. No. And last, alternate exterior angles. So outside of my two, in this case, non-parallel lines, Q and R, 95 is above the blue line, 30 is below the blue line. So we could say angle 4 and angle 8, and we would also say no, that those did not work out to be congruent. So when you have two parallel lines that are cut by a transversal, corresponding angles, alternate interior angles, and alternate exterior angles are all congruent. When non-parallel lines are cut by a transversal, we do not get congruent pairs. The one that holds true are vertical angles, and that's because vertical angles are on one vertex. They're always on a single point of intersection, and they're not relying on those parallel lines. Use the figure below to answer the following questions. Assuming that the measure of angle 1 is 110 degrees. All right, so I'm going to label that. We're going to assume that angle 1 is 110 degrees. Could you know the measure of angle 4? Well, these two angles that are next to each other, angle 1 and angle 4, would be supplementary. And we know that supplementary meant adds up to 180 degrees. So if this one's 110, we should be able to get angle 4 because they've got to add up to 180. 110 plus blank has to equal 180. That makes the missing angle 70 degrees. How do we know? Because those two angles that are next to each other are supplementary. So if you wanted to, if it helped, you might highlight and say angle 1 and angle 4. You'll notice that they make a straight line here underneath. They are supplementary. How about angle 7? What's the measure of angle 7? Explain how you know using new vocabulary. Well, angle 7 down here, if you'll notice, it's opposite angle 1 that's right above it. So you might go with vertical angles on this one. This would be kind of nice, right? Angle 1 up here, angle 7 down here. They open in opposite directions. And if they are vertical angles, one opening up, one opening down, they would be the same measure. So it would also be 110 degrees because they are vertical angles. Vertical angles are great. They are probably the one that I use most often. And how about the measure of angle 8? Now, you'll notice the angle 8 is obtuse. It's open greater than 90 degrees. If we are assuming that A and B are parallel, right? We're going off of that theory that A and B are parallel. If A and B are parallel, then we can say angle 1, which is up here above the transversal, and I can label this transversal blue. Angle 1 is exterior and it's above the transversal. Angle 8 down here is below the transversal. They would be alternate exterior angles. If this one's 110, notice how obtuse it is. This one would also be 110 degrees because it is an alternate exterior angle to angle 1. And so that would make them the same measure. Now, there's lots of different ways you could have done this. You also could have said that angle 7 is 110, and it's a corresponding angle to angle 8, making it also 110. So there is more than one way to answer this question. I happen to go with alternate exterior.